Hi everyone! In this video I'm going to show you this clamping tool which clamps on the inside diameter. The base body is a rotationally symmetrical part in which steel balls are mounted which are able to move in radial direction. These balls can practically be bearing balls which are available in different sizes. This tool consists of the following parts: the base body, support with an anti-twist groove, fixing screws, threaded rod with a shoulder, a dowel pin, two identical tensioning elements made of hardened steel to prevent impression of the balls. Changing the angle of the cone affects the clamping force. Self-locking can occur at certain angles, making it difficult to release the workpiece even after loosening the nut at the top. A strong tool spring, many brass bushings, a lot of bearing balls, a washer and a nut to create the clamping force. The bushings can press fitted or glued into the base part. At the end there is a small flange to prevent the balls from falling out. Using some higher density grease, the balls won't fall inside during assembly. The pin prevents the rotation of the threaded rod while allowing free movement in the vertical direction. At this assembly phase, the pin also prevents the rod from falling out. The tensioning parts are guided inside the center hole with tight tolerances to ensure concentricity. The lower one is resting on the support part, so the balls are not yet forced outwards. The tool spring is holding the upper one, so the balls are not forced outwards here either. In this state, the workpiece can be pulled onto the tool. Because the movement of the balls is in a radial direction strongly restricted, the bore of the part to be clamped must be only a few tenths of a millimeter larger than the diameter of the base body. Let's assume that the spring is untensioned and the nut is loose. There might be a gap here. Let's start tightening the nut. After the shoulder of the screw reaches the lower tensioning part, the spring starts to compress. The upper tensioning part moves downwards and reaches the balls. When the balls reach the workpiece, the upper part cannot move down any further, so the lower part starts to move upwards and starts to push the lower balls out. If we keep tightening the screw further, the clamping force will increase. Please note that in case of soft materials, the balls may leave marks on the inner surface of the workpiece. Of course, the tool can be fixed to anything with screws. At the end of this video, as always, I collected some advantages and disadvantages. Advantages are: the tool holds the workpiece stable on the inside diameter, many contact surfaces, accurate positioning, easy to use. The disadvantages are that the design is complex and there are a lot of parts. The useful diameter range is limited. If the bore of the workpiece is too large, the boss can be pushed out too much, what can destroy the flange or push the whole bushing out. Maybe a rubber flange can be used instead of a rigid one, so the boss can fall out and then be pushed back without causing any damage. For this, a different bushing design is needed, using maybe O-rings as a flange. What do you think about this tool? Feel free to share it in the comment section. Thanks for watching. Bye.